Section 2.2 is all about conditional statements, what should be new to you. So let's first define what a conditional statement is. A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. So if you think back to science class, when you start an experiment, you start off with a hypothesis, the first part, and a conclusion is what you get at the end. So it's a lot like that, where the beginning is the hypothesis and the conclusion is the end of the conditional statement. Conditional statements are often written in a certain form. This form is called if-then. When a conditional statement is written in if-then form, the if contains the hypothesis and the then contains the conclusion. So again, the if is the hypothesis and the then is the conclusion. Let's see an example. This is my favorite one that my favorite college professor always talked about. If it is raining, then there are clouds in the sky. So you can see here that this is an if-then form. So the if identifies the hypothesis and the then identifies the conclusion. So it is raining is the hypothesis and there are clouds in the sky is the conclusion. Let's get some practice on actually writing conditional statements in if-then form. This is trickier than what you expect it to be. Rewrite the conditional statement in if-then form. Part A, all whales are mammals. To go about this, I would first identify what would have to be the hypothesis. Would being a whale be the hypothesis, or would a mammal be the hypothesis? The way I think about this is if something is a whale, then it is a mammal. So the whale part would be your hypothesis and the mammal part would be your conclusion. So to write this in if-then form, if an animal is a whale, then it is a mammal. Notice how I used the noun in the first part, animal, and then I change it to like a pronoun in the conclusion. So the it that it's referring to here would be the animal, and you can do that in your own if-then statements as well. Part B, 3 points are collinear if there is a line containing them. This one's easier because do you see this word if? The word if is indicating that this would be the hypothesis. So to write this in if-then form, if there's a line containing 3 points, then they are collinear. So notice how I had to change some of my words around here. If I had just written this as it was given to me, if there is a line containing them, that wouldn't make any sense because why would I use this pronoun when I haven't identified what them is referring to? So them in this case was referring to the 3 points. So I had to switch those words around. If there is a line containing the 3 points, not just them, but the 3 points, then they, which is referring to them, are collinear. So sometimes you have to flip some words around just to make the sentence make sense. It would not have made sense if I said if there's a line containing them, since them had not been previously identified as the 3 points. So I had to identify the 3 points first in the hypothesis to then refer to them as they later in the conclusion. Let's take a look at some more vocabulary. The negation of a statement is the opposite of the original statement. So to negate this statement, the dog is yellow, I would write, the dog is not yellow. The opposite of being yellow is not being yellow. So that would be the negation of that statement. That brings us to some related conditionals. Basically, the next 3 things are just how we can play around with conditional statements. The first part is a converse of a conditional statement. To find the converse of a conditional statement, you're going to exchange the hypothesis for the conclusion. For the inverse of a conditional statement, you're going to negate both the hypothesis and the conclusion. And finally, the contrapositive is putting the converse and the inverse together. So first, you will write the converse, which remember, that just means flip the hypothesis and the conclusion around. And then you'll negate both the hypothesis and the conclusion. So again, the contrapositive is just like putting the converse and the inverse together. So converse is when you flip the hypothesis and the conclusion around. Inverse is when you negate both the hypothesis and the conclusion. And then the contrapositive is kind of the child of those two where you put them together. So you make the converse and then you negate both the hypothesis and the conclusion. In example number 2, we'll get some practice doing all of this. First, it says write the if-then form, the converse, the inverse, and the contrapositive of the statement. Soccer players are athletes. So again, I think the toughest part is figuring out how to write that as an if-then statement. So the way I think of it as we have soccer players that are athletes. So if you are a soccer player, then you're an athlete. So that's what we'll write for our if-then statement. If someone is a soccer player, then they are an athlete. Next, when we do the converse, remember we're going to flip the hypothesis for the conclusion. So the hypothesis was someone is a soccer player. The conclusion is they are an athlete. So for the converse, it would look like this. If someone is an athlete, then they are a soccer player. So once again, we need to look at the nouns in this. It says someone and then they. So notice when I flip this around, I didn't say if they are an athlete, then someone is a soccer player. I had to keep the noun someone in the hypothesis, and I kept they in the conclusion. So just be aware of those types of changes. Next, for the inverse, we're just going to negate the original if-then statement. So it'll look like this. If someone is not a soccer player, then they are not an athlete. So again, we just negated by putting not in front of both the hypothesis and the conclusion. And then finally, for the contrapositive, we will take the converse and then just negate it. So the converse was, if someone is an athlete, then they are a soccer player. So now to change that into the contrapositive, I'm just going to put not in front of not an athlete and not a soccer player. So it'll look like this. If someone is not an athlete, then they are not a soccer player. So again, the contrapositive is found by taking the converse, where you flip around the hypothesis and the conclusion, and then just negating it by putting the words not in there. So just because we wrote these doesn't mean that they're necessarily true. For example, for the converse, if someone is an athlete, then they are a soccer player. That's not true. Just because you're an athlete doesn't necessarily mean that you play soccer. You could be an athlete and play basketball. You could be an athlete and play badminton. It doesn't matter what sport you play, but just because you are an athlete doesn't mean you play soccer. At the same time, with the inverse, if someone is not a soccer player, then they are not an athlete. That's not true either. Just because you don't play soccer doesn't mean that you can't play some other sport and be an athlete. So again, just because we write these doesn't mean that they're necessarily true. We do have some similarities here that do need to be noted. A conditional statement and its contrapositive are either both true or both false. So in our example here, the original conditional statement was, if someone is a soccer player, then they are an athlete. That's true. If you play soccer, that means you're an athlete. So therefore, since the original conditional statement is true, we automatically know that the contrapositive is true. If someone is not an athlete, then they are not a soccer player. So if you're not an athlete, that means that you don't play any sport, so you're definitely not a soccer player. So again, if you know that the original is true, then the contrapositive is true. If the original had been false, then the contrapositive would have to be false. Similarly, the converse and the inverse of a conditional statement are either both true or both false. We already saw this. We saw that our converse in this case was false. If someone is an athlete, then they are a soccer player. That's not necessarily true, like we said, because you could play some other sport other than soccer and still be an athlete. So since that we knew that the converse was false, we automatically know that the inverse also has to be false, which we saw before as well. If someone is not a soccer player, then they are not an athlete. Again, that has to be false, because just because you don't play soccer doesn't mean that you can't play some other sport and still be an athlete. So again, either the converse and the inverse are both true or they're both false, but not at the same time. When two statements are both true or false, they are called equivalent statements. So in our case, if someone is a soccer player, then they are an athlete, would be equivalent to the statement, if someone is not an athlete, then they are not a soccer player. Also, if someone is an athlete, then they are a soccer player would be equivalent statement to, if someone is not a soccer player, then they are not an athlete. So if something's both true at the same time or both false at the same time, those are called equivalent statements. With that being said, that brings us to definitions. You can write a definition as an if-then statement, so the original conditional statement, or its converse, where you flip the hypothesis and the conclusion around, and they would both be true. So we'll see this when we talk about what the definition of perpendicular lines are. Reading this, we see it as, if two lines intersect to form a right angle, then they are perpendicular lines. That's true. We've learned that before. You've heard that before in other classes. We know that if two lines intersect and form a right angle, they're called perpendicular. So if we flip those around to make the converse, it would look like this. If two lines are perpendicular lines, then they intersect to form a right angle. That's also true. So therefore, we know this is a definition. So again, a definition can be written same forwards and backwards. You can say it as the original if-then, or you can flip it around where you take the hypothesis and put it in place of the conclusion, and it would still be true. While we're talking about perpendicular lines, let's also identify what the symbol for perpendicular is. This is the symbol, which looks like an upside down T, but I wouldn't necessarily think about it as an upside down T. I think of it as this line being perpendicular to this line. So again, don't think of it as an upside down T. Think of it as those two lines that represent the symbol for perpendicular are actually perpendicular to each other, and I think you'll have a better time remembering it. Example number 3 has us analyzing a diagram and deciding whether each statement about the diagram is true. So for the first part, A, it says line AC is perpendicular to line BC. So when I look at this, I see AC right here and BC right here, and we're told that they are forming a right angle. Therefore, this statement is true because that's the definition of perpendicular lines. Next, we have part B. Angle ACD and angle DCB are complementary. So keep in mind, complementary means that two angles add up to 90 degrees. So therefore, a 90-degree angle is a right angle. So when we see in our diagram, here's ACD and DCB, and they're forming this right angle. So this would also be true. Part C says ray CD bisects angle ACB. Keep in mind that bisects means that that ray is cutting that angle into two congruent angles. Since we see that one angle is x and the other is 2x, there's no way that x could be equal to 2x as long as x is positive. So therefore, this would have to be false. Let's move on to some more vocabulary. A biconditional statement can be written when a conditional statement and its converse are both true. So when I see the prefix bi, I think of two, like a bicycle has two wheels. So whenever I think of a biconditional statement, I know that the conditional statement and its converse, so when I flip the hypothesis and the conclusion around, I know that they're both going to be true. So both meaning two, which brings me back to the prefix of bi. So therefore, every definition can be written as a biconditional statement. Think back to when we were defining perpendicular lines. We saw that the original conditional statement was true and also the converse was true when we looked at that definition. So every valid definition can be written as a biconditional statement. Whenever we write a biconditional statement, we use the phrase if and only if. You can abbreviate if and only if with the word IFF. So really that just looks like a typo, but if I saw the word IFF, I don't read it as just if with like a long stressed out F. I read that as if and only if. Again, math is just like its own language. So this is just another word in the math language that you need to learn. So again, if you see the word IFF, that doesn't mean to just stress the F when you say if. It's read as if and only if. And again, we use that in biconditional statements, and typically when you're writing biconditional statements, it's when you're writing definitions. Example number 4 has us practicing writing definitions as biconditional statements, specifically the definition of supplementary angles. So let's first just define what supplementary angles are. If the sum of two angles is 180 degrees, then they are supplementary. Notice that I made the hypothesis red and the conclusion blue, so we can identify those later when we are writing the biconditional statement. Next, let's write the converse, because remember, biconditional statements, the conditional statement is true and the converse is true. If two angles are supplementary, then their sum is 180 degrees. So here again, for a converse, I just flipped the hypothesis and the conclusion around. But notice the nouns that I had to change. In the blue, I had they, but again, it wouldn't make sense if I said if they are supplementary because we haven't identified what they are. So I had to change they to the two angles, and then I just said their sum is 180 degrees rather than stating the two angles again. So now let's actually write the biconditional statement. It would look like this. Two angles are supplementary if their sum is 180 degrees. I could have also written it like this. The sum of two angles is 180 degrees if and only if they are supplementary. It didn't matter what order we put them in because we knew that the original and the converse were true. All that matters is that we put them in the correct form with the if and only if in the middle. And remember, that is not a typo. When you see IFF, read it as if and only if. If that bothers you, then actually write out the statement if and only if. That's it for this section. This is a pretty difficult section, so make sure you come to class with all the questions that you need to have addressed so that we can move forward. This is a very pivotal section, so make sure, again, if there's anything you didn't understand, jot those questions down now or put little stars next to different things so we can cover them in class. We'll see you then.